So number 12, you have to simplify and write it in standard form. So you can rewrite it as 7 minus the square root of 25 times the square root of negative 1. So then square root of 25 is 5, square root of negative 1 is I. So in number 15, I squared is negative 1, but there's a negative in front of it already, in front of the term, so that's negative minus a negative 1, that's positive 1. So we write the real part first, minus 8i. So the square root of negative 23 squared, remember when you square a square root, you keep the radicand, the number in the inside, just as it is. So this would be negative 23, but then there's a negative in front, so a negative times a negative is positive, so you get 23 minus I. So in 21 we're subtracting. So remember the negative is distributed here and here. So it's 4 minus 7, and then I minus a negative 2, that's plus 2, so that's 3I. So on 24 we're combining like terms. There's no need to change signs because we're adding. So 7 plus 3 is 10, 6i plus 12i is 18i. Okay, so for this problem we're adding just like number 24, except these are fractions. So we need a common denominator. So if you compare the real with the real, 2 and 3 are my denominators, so my least common denominator is 6. So the first fraction I'm going to multiply by 3 over 3, and this one would be the 5/3, it's 2 over 2. Okay, and so that's going to give me 9 over 6 plus 10 over 6. That's for the real part. Now for the imaginary part, this part and this part, same denominator, right? 6, because I've got a 2 and a 3. So the 5/2 I'm going to multiply by 3 over 3, and the 11/3 I'm going to multiply by 2 over 2. So 5 times 3 is 15 over 6i, and then plus 22 over 6i. So I'm going to add these together. So now I get 19/6 plus 37/6i, and that's your final answer. So here I've got to change signs in both complex numbers and both imaginary numbers, right? So this negative is going to change the signs right here, and this, when I subtract, I'm going to add the opposite, right? So this 3.7 is positive 3.7 and then minus 6.1. So that's going to give me a negative 2.4, right? And then the 12.8i is actually positive 12.8i, and then 16.3 is positive 16.3i. So when I add 12.8 and 16.3, I get positive 29.1i, and that would be your answer there. So we're multiplying on number 33, so again, straightforward distributive property. So this is going to give you 3 minus 2i, and then you move on to the I times 3 is 3i, and minus 2i squared. Now remember, I squared is negative 1, so this term right here is going to actually be plus 2. And so now we combine like terms, and I've got 3 plus 2 is 5, and then these two right here is going to give me I. Okay, so we're going to distribute the negative 3i, so we get negative 18i, and then positive 3i squared. But remember, the I squared is negative 1, so this is actually negative 3, so it's negative 3 minus 18i. So we're squaring a binomial. Okay, so this gives me 36. 6 times 7 is 42. You double it, so that's 84. And then 49i squared. This is negative 49, so when you combine it with 36, you get negative 13. And then the 84 stays as it is. And there's your answer. Alright, so we're going to square two binomials and then subtract one from the other. So let's go ahead and do the squaring. So that's 1. 1 times negative 2, you double, you get negative 4i, and then you square negative 2i, you get positive 4i squared. Then minus 1 times 1 is 1, 1 squared, 2i times 1 is 2, you double, you get 4i, and then 2i squared is 4i squared. Oops, squared. So remember, this negative is going to change all the signs inside, right? So 1 minus 1 is gone. Negative 4i minus 4i is negative 8i. And 4i minus 4i is 0. So there's your answer. Okay, so for number 45, you have to find the conjugate and then multiply the given number by its conjugate and see what you get. So the conjugate for number 45 is negative 1 minus square root of 7i. Remember, the sign of the real part does not change. So now we're going to multiply the conjugate by the given number, by its conjugate, and we get 1. Negative times the negative is positive, so radical 7i. Then these two right here is negative radical 7i. And then this one with this one, so that's negative 7i squared. And so negative 7i squared is actually plus 7. So we get 7. Oops, I forgot to write the plus in between here. Sorry about that. So then 1 plus 7 is 8. And then these two cancel. They have to. That's the purpose, or that's why we use a conjugate. So we cancel that. Number 48, you can simplify this as radical 10i. The negative square root of 1 is I. And so the conjugate would be negative radical 10i. So we're going to multiply this by the given number. And so this gives me negative 10i squared. But remember, I squared is negative 1, so the answer is 10. On 51, we're dividing, so we have to multiply by the conjugate. So this gets multiplied by negative I over negative I. So you get negative 6i over negative I squared. Well, I squared is negative 1. There's a negative in front of it already, so this becomes 1. So then you get negative 6i over 1, negative 6i. So again, another division, so we're going to multiply this by its conjugate, which conjugate of the denominator. So that's 1 plus I. So that's going to give you 3 plus 3i over 1. Now, I know that this times, when I combine those two, they're going to cancel out, so it's minus I squared is what I'm going to have left. And so minus I squared is a plus 1, so this gives me 3 plus 3i over 2. And so I'm going to separate it into the real part and the imaginary part. So this is standard form. So 57, before I can look for the conjugate of the denominator, I've got to simplify that denominator. So this is going to be I over 16. Now 4 times 5 is 20. You double, you get 40. And then negative 5i squared is, when you square it, you get 25i squared. So remember, this is negative 25. So then that gives me 16 minus 25, negative 9, minus 40i. So now I could use I could look for the conjugate of the denominator. So it's going to be negative 9 plus 40i. So remember, this fraction that I'm writing right now has to equal 1. That's why the numerator and denominator are the same. And, okay, so then I have negative 9i plus 40i squared over 81. Now remember, this and this are going to be 0 when you combine them. So then you basically just need to square the first number, square the last number, which gives you negative 1600i squared. So then this I squared here is going to make this a positive 1600. So it's 1681, the denominator. And then 40i squared is negative 40. So negative 40 minus 9i. So just separate it, real part from imaginary part. Like this. That would be the answer. Okay, simplify and leave in standard form. So I cubed is negative I, so this is negative 6 times negative I, and I squared is negative 1. So then I end up with negative 1, because that's what you get here, and this is 6i. Alright, so I'm going to break up that negative 75 into different factors so I can take out, because I'm taking the square root of this number cubed, right? Or yeah, or I can, yeah, I guess you're cubing the square root. So either way, I'm going to break this up into -1 times 25 times 3. And each of these are being cubed. I'm taking the square root of that. Okay, so I can take them out in pairs. So this one comes out in pairs, so you get -1 outside, but then you still have a -1 left inside, right? 25 comes out. Oh, actually, 25 comes out as 5. Sorry, take it back. Let me erase that. So the 25, square root of 25 is 5, and there's 3 of them. So this is 5 to the third, and nothing is left inside. And then for the 3 cubed, I could take out a 3, but then 1's inside, because I have 3 of them, right? So now this becomes out here 125 times 3 times -1, -375. And then this is square root of 3, and then the square root of -1 is I. So this would be the final answer. So 87, I cubed, I know that is -I, right? So now I'm going to multiply by the conjugate, which is +I, conjugate of the denominator. So then I get I over -I squared. Well, I squared is -1, and there's a negative in front of it, so it's a 1. So the answer is I.